Hello, this is Mr. Sarisa, and today we're going to go over the problem that I went over in class. And this was with the three runners. The first one finished, the second one was a mile behind him, and then the third runner was 3 more miles behind, or 4 miles behind the winner. And so what we're trying to do is find out how many miles the second place runner beats the third place runner. And so like I always say, just set up what you know, and then we'll figure out what we don't know. And so first I'm going to make a table just to see, or just to show what I know. So I have the first place person, the second place person, and the third place person. And I'm going to make a table. Seeing that I'm talking about distances and rates, then I'm going to use distance, rate, time. So remember, distance equals rate times time. I don't remember if I had talked about the dirt pizza. And so if you want distance, you cover over the distance and it's rate times time. If you want time, you cover up the time and it's distance over rate. So you can figure out all these just knowing what the distance, rate, and time is. So the problem says when the first person finishes, that means they ran 50 miles. The second person is a mile behind, so they ran 49 miles. And the third person is 3 more miles back, so they ran 46 miles. And then, obviously, if they're at different distances, then they must have run different rates, but we don't know what that is. So I'm just going to call it R1, R2, and R3. And then finally, this is just a snapshot at when the winner won. So they all have been running the same amount of time. And so I'll just put all the T's in for that. Now I'm going to set up things that I know. Well, this is what I know, but I'm going to set up equations to make connections. So I'm going to figure out R1, and to do that, I need to use that dirt pizza I was talking about earlier. So all the T's are constant, which means the time is the distance over rate, so 50 over R1. But that's also true for R2, but it's going to be 49. And then 46 for R3. So I just did all the distance over rates and set them equal to each other because they've been running the same amount of time. So to go back to the equations I was coming up with, that R1 now, we just use two of the proportions, or two of the ratios, set up a proportion, we take the cross product. So if I want R1, then I just do 50 times R2 divided by 49. And then I'm going to do that for all three of these rates. So 50 times R2 all over 49. And then for R2, I don't want to do it in terms of R1 because then I really just have the same equation just looking the other way. R2 is just 49 over 50 times R1. So that's not going to get us anywhere. We want to keep doing this and using different terms. So R2 is going to be 49 times R3 all over 46. And then finally I'm going to use R3. And R3, I'm going to connect that with R1. So R3 is 46 times R1 all over 50. So this doesn't look like much right now, but we're going to start using the information that we don't know in order to connect it. So this is everything that we know. And what we're trying to find out is what it says, how many miles does the second place runner beat the third place runner? So the best way is not to do that directly, but to figure it out using other information. So if I go back to the distance, rate, time, I didn't really give myself much room here, but that second runner, when they ran 50 miles, and they're still going the same rate, R2, they are now at a different time, so T2. And we have the third runner. We don't know how far back the third runner is, so I'm going to have to write this over here. But the third runner is X amount of distance. They're running R3, but they're also doing T2. They run for a T2 amount of time. And so that T2, just using the same method that we had before, that T2 is now going to be 50 over R2. And that will equal X over R3. Okay? So we just want to connect one of these, R2 or R3, with one of the R1, R2, R3s. And so probably the easiest thing to do, because we only care about 2 and 3, I'm going to use this one right here. R2 is 49 over 46 R3. And then I'll solve for R3 over here. So, in other words, R3 equals X times R2 all over 50. Alright, once I know that, I'm going to take R3, plug it into this R3. So, let me rewrite R2 as 49 over 46. But instead of R3, I'm going to plug in this X R2 over 50. So I'm working that out here. And remember, our goal, of course, is to find out what X is, so I'm going to isolate that variable. One thing I can do is divide both sides by R2, because there's an R2 on each side, so they cancel. And that means this whole thing really equals 1. Okay? And now to get X by itself, I need to divide by 49, multiply by 46, and multiply by 50. And so if I divide by 49, I get rid of that, multiply by 46, I get rid of that, and then divide by 50, I get rid of that, and I'm just left with this X right there. So all of this just equals X. And so when I multiply that out, I get 46.94. And so that X, though, that's where the runner is. I should have defined my variable earlier. But X is where the third place runner is when the second runner finishes. And so the question doesn't ask where the third runner is. It asked how many miles does the second place runner beat the third place runner. So the second runner actually just finished the 50 miler. So the second runner is at 50 miles. And the third runner is at 46, so if I subtract them, I find out what the difference is between them. So that ends up being 306 miles behind the second runner when he finishes. Okay, I hope that this helped. Thank you.